So next up in the final lesson for 8th grade pre-algebra is 5-8, which is scale drawings and scale models. We have 5 vocab words here, so if you would pause your video, do your heading, your vocab, and then come on back. So our vocab, scale drawings are two-dimensional drawings of an object that is proportional to the object. So we're keeping everything in scale. They're all going to be proportional to each other. The scale is the actual ratio that you use to go from the real object to the scaled object, like a map versus a park. Okay. Scale model is the same thing as a scale drawing, except now it's a three-dimensional object that you are making a scale of rather than a two-dimensional object. Reduction and enlargement. So a reduction is where your drawing or your model is smaller than the actual model, and an enlargement is where the drawing or the model is actually larger than the real object. So an example of a reduction would be pretty much any map that you've ever seen. So typically, you have this enormous park and they make a paper map of it, a scaled drawing of a map. Those are reductions, where you're taking the huge park and turning it into a simple piece of paper, small piece of paper. The opposite of that is an enlargement. So this is something where you take something like a heart and you enlarge it, you make it bigger into a 3D model that is bigger so that you can see the details. Same thing with any DNA model. DNA is microscopic. They make it into an enlargement, which is a bigger version that you can actually see the details of the DNA. So these are very real world things that you will encounter in your life. The first example here is about a scale drawing. It says the length of an object on a scale drawing is 8 centimeters and its actual length is 48 meters. So on the drawing it's 8 centimeters, but the real thing is 48 meters. So we're trying to figure out what the scale is here, and we are told that the scale is 1 centimeter to some amount of meters, and we don't know what those meters are, so we put our X there, and we say that we have 8 centimeters to 48 meters, and that is equal to our scale, which is 1 centimeter to X meters, and we're going to cross multiply. Lots of cross multiplication happens in this chapter. We divide by 8 here and we get 6 meters. So our scale is 1 centimeter to 6 meters, which we can write in two ways. We can either say 1 centimeter over 6 meters or 1 centimeter and then the colon. So remember that ratios can be written in either way. Next up, we have a map, and it's showing that the distance between two shelters is 1 75/100 of an inch, and that is of course on the map, not the actual place. And then we are told that our scale is 1/4 inch is equal to 2 miles. So 1/4 of an inch equals 2 miles. And we, of course, are charged to figure out how many miles those two shelters are apart from each other. So we are going to cross multiply. I'm going to change that quarter into a decimal. And we would have that. Oh, I lost my X. And then we're going to divide the whole thing by a quarter. And we get that x equals 14. So the two shelters are 14 miles apart, even though on the map they're less than 2 inches apart. The next one, we have a model of a house. So this is something that architects use. They will make a 3D model of the building that they're designing. And it says that the model of a 30-foot tall house was made using a scale of 3 inches to 2 feet. So we are supposed to figure out what the height of the model would be. So if we have 36 feet, and we know that the scale that was used, the scale that was used was 3 inches to 2 feet. Let me write this down. So 3 inches to 2 feet. And we know that the model is of a 36-foot tall house. We're supposed to figure out what the height of the model would be. So it's saying that this house is 36 feet tall. We're supposed to figure out how big the model is. If for every 2 feet we have 3 inches in the model. So what we can do here is we can do it a couple of ways. So I'm just thinking in my head of a different way to do it than what's in the book, and I'll show you both ways. But if we know that every 2 feet is 3 inches, if we divide this by 2 and then multiply by 3, that would give us our answer. So if I say 36 divided by 2 equals 18, and then I'm going to take that 18 times 3, then this would equal 54. That seems really hot, a really tall model, but it's 54 inches. That's the right answer. The way that they show you in the book is to take your scale, which is this 3 inches over 2 feet, and they're changing this 2 feet into inches. So they then can say that 3 inches is the same thing as 24 inches. So that both of these are in inches. And then they've reduced that. So they've divided this by 3, divided this by 3. And you get 1 to 8. 1 to 8. So now they can say that 1 to 8 equals x to 432, which is 36 times 12, because there are 12 inches in every foot. So they did that, and then they cross multiplied, divided, and they got the same thing of x equals 54. Frankly, I like my thinking method better than this mess. So as with most things in math, there's more than one way to get the answer. Do what you're more comfortable with. I definitely would go this way on this one. I just think it makes a lot of sense when 36 and 2 worked really well together, and then you could multiply by 3 and get your answer. That's up to you. If you like this way, go for it. The last one is about a DNA model, which we know Mrs. Schoenfeld would like. So the DNA model is made using a scale of 2 centimeters to, let's see, how many decimal places is this? 1, 2, 3, 4, 5, 6, 7. So it would be 1/10,000,000th of a millimeter. DNA is pretty tiny. And let's see, the model of the DNA chain is 17 centimeters long. What is the length of the actual chain. So we can say that the model is 17 centimeters. See, these ones aren't going to work quite as neatly. So if we divided this by 2, we'd get a decimal here, and it wouldn't work out quite as nicely. So let's do this one the way they did it in the book, which is to change this to millimeters so that those match. And let's see, there are 10 millimeters in a centimeter. So this would be 20 millimeters over 1/10,000,000th. And then if we divide this out, so 20 divided by 1/10,000,000th, we would get 200 million. So this actually equals 200 million, which means that that DNA model is 200 million times bigger than actual DNA. That's impressive. That's very impressive. All right, so knowing that, we can say that 200 million over 1 equals 17 centimeters over 1 centimeter. We would cross multiply this, and oh, I'm sorry, that should be x. So we would get that x equals 17 divided by 200 million, and we get that x equals, oh dear, count the zeros. So we'd have 1, 2, 3, 4, 5, 6. This is millions. So 10 millions, 100 millions. So this would actually be billionths. 85 billionths. Wow. So they have changed this into scientific notation, which is a little bit easier to think about. 8 and 5/10 times 10 to the negative 8th, because we moved that decimal 8 places over. So 8 and 5/10 times 10 to the negative 8th centimeters. Wow. That's how, sorry, that's like mind-boggling to think about how small a DNA chain really is. 85 billionths of a centimeter. I mean, centimeters to begin with are pretty small. 85 billionths of a centimeter? That's tiny. Tiny. Wow. To say microscopic, it has to be a really strong microscope. Alrighty. So what I would like you guys to do on this lesson is page 262, 5 to 8 all. Another short homework assignment there, 4 problems. Try those and then watch your homework review. See you all soon.